Hello students, today we'll see C++ program to implement Triadic Koach. First we'll see small introduction of Triadic Koach and then we'll see how we can implement program for it. So Triadic Koach basically it is a fractal. So first we need to find out the position where we want to generate this curve. So here we can see the various generation of Triadic Koach curve. So initially there is a single line which has a starting and ending point. So here we want to generate this curve. So very first step is this entire length is divided into three parts. So we need to find out that position so that we can divide it into three parts. Then this line will be having first part, middle part and last part. Whereas first and last part will be remain same. Whereas middle part will be converted into two line segment and there it will form a structure like a equilateral triangle. But one line will be invisible. So one single line will be converted into four small line segment. So same task can be repeated in number of times and we can go in more depth. So this way triadic Koach curve can be generated as we are following the same procedure. So here we can use the recursive function to implement it. So here we can find out the fractal dimension of this triadic Koach curve. So here there is a formula to find the fractal dimension. So here we are using, we are scaling down this line segment by 3. So S is 3 here, whereas 4 line segment will be generated from 3. So N is 4 and D is the fractal dimension. So D can be calculated as log 4 by log 3 which is 1.26. So this value is greater than the topological dimension. So that is the way we can prove that this is a fractal. So just we'll see how we can implement this. This is a small C++ program to generate the triadic Koach curve. So here first we have added all the header files which are required. Then there is a function to generate the Koach curve and after that there is a main function. So in main function we have to first initialize graphics driver and graphics mode. Then with the init graph function we'll initialize graphics mode. Then the very first step to generate the Koach curve is to find the position where we want to generate this curve. So for that we have taken two points x1, y1 and x2, y2. So we have given some values for x1, y1 and x2, y2. So we are just using these four values and passing it to Koach function. So this Koach function will then generate the entire curve. Along with this 4 value, we are passing the depth value. So here we have passed 2. So it will go at second level. So this 5 value will be used to call the Koach function. So here I have considered a triangle position. So I have considered triangle. So 3 sides and 3 times I am calling this function so that it is extended in 3 directions. But it is not compulsory. You can run it for one single line also. So after calling it will go to Koach function. So we'll see how this Koach function is working. In this Koach function its return type is void. It function doesn't return anything, so return type is void and we are passing 5 parameters. First 4 parameters are for starting and ending point and the last parameter is for iteration. So in diagram you can see that middle portion line is it is extended, it is lifted by 60° in upward direction. So here the angle value is 60. So for processing we need to convert this angle value into radian. So very first step in Koach function is where we are calculating the angle in radian, where we are using here m underscore pi function pi, which is a macro and it is predefined macro which is defined in maths.h header file. So its value is 3.14. It's for pi value. So with this formula we are converting this angle into radian. The next 4 line where we are finding the two points, that is x3 y3 and x4 y4. So here to calculate this x3 y3 we have used the formula like 2x1 plus x2 divided by 3. Similarly y3 is calculated 2y1 plus y2 divided by 4. In the same way x4 and y4 are calculated. So there are many ways to find out this intermediate position, as this is x3 y3. This point is, it comes after the one third position, and x4 y4, this is the two third position. So this can be calculated in some different way also. So here I have used this formula. Once we have got this x3 y3 and x4 y4, we can find the value of x and y. So x and y is another point of the imaginary triangle here. So this we can get by calculating the height of the triangle. If we consider x3 y3 and x4 y4 as a base, so height value can be calculated, so that we'll get the x and y. So accordingly x and y will be calculated by using this formula. So whatever value we'll get, that will be added into x3, so we'll get x, and with formula we'll get the y value, that will be subtracted from y3. So after getting all these intermediate points value, now we can draw all these line segment. So before that we have to just check what is the value of iteration. If iteration value is greater than 0, means again we have to go in depth. So if it is greater than 0, then same function will be called for this individual line segment. So there are 4 line segments, so 4 times same function will be called for this individual small line segment. So here you can see the first function calling for x1 y1 x3 y3, then second function calling for x3 y3 xy, then third is for xy and x4 y4, and fourth one is between x4 y4 and x2 y2. So same task will be repeated. So while calling Koach function for this all small line segment, the iteration value will be decremented by 1. So this function will be called again and again if iteration value is greater than 0. But if it is 0, then we need to draw line segment there. So in else part we have written the code to draw the line. So this is a built-in function, line function. So where line will be drawn between x1 y1 x3 y3, second line will be drawn x3 y3 xy, fourth will be xy to x4 y4, and fourth line from x4 y4 to x2 y2. So this one function will be used to draw Koach curve for one position. If we call this function 3 times, then it will draw this Koach curve at 3 different positions. So this way we can implement the triadic Koach curve. Thank you.